All right, so please have your notes ready. Shh, boys. It's already recording. Have your notes ready. We're going to do chapter 3D on recurrence relations. All right. So what I've noticed in teaching, this is probably the third year that we've taught this in year 10. In year 11, when we teach, this is the first, also in year 11, like 3 years ago, before we started teaching this. This was new to everybody. Like, you guys have never learned this before, right? I'm assuming. Or never learned patterns like this. So, one of the difficult things we find if you're learning this for the first time is all the words. There's so many words that you're learning about. Recurrence relation, arithmetic sequence, common difference. Yeah, they're all big words, but in essence, they're actually quite simple concepts. Yeah, they're not actually hard to understand once you get it. So if you're listening to this and you understand all the concepts already, that's really, really good because then you're well equipped for year 11. Yes, Donovan. With finance, yes. So when it comes to money and finance, if you ever invest money, is that depending on what kind of plan you go in, each month or each year, you actually gain a certain amount of money. And so, if you think about patterns, and here and what we're learning about is how patterns go up and go down, right? So, in terms of money, you might be learning about, all right. So, if Donovan invests like $100 in his account at the start of this year, how much will he have at the end of the year if he gets this much every month? It could be that kind of question. Or if you're wanting to pay off your loan over 50 years, okay, and you've borrowed like $100,000 and then you need to pay a certain amount each year, how much are you going to pay each month? So what would the common difference be so that you finish paying after 50 years, for example? It's those sort of questions for finance. So it's not so much about interest or principal or rate or time, although that is in here. It's not how you learnt it back in year 9 or year 8. It's a little bit different. Okay? Karan, can you close your laptop, please? All right, so let's do this. We're up to this page, guys, where it's page 6 on your notes. So if you're not there, please follow along. But recurrence relations is what we're learning about here. So the two new words that we're hearing or learning about here is this word, recurrence relation. Okay, anyone want to tell me really quick, what does arithmetic mean again? What's arithmetic mean? Going up and down by the same amount. Same amount. Okay, that's what arithmetic means. We're going up and down by the same amount. But then what the heck does recurrence relation mean? So let's get into that. Sorry? Not quite. But you're kind of on the right track there. It's something. No, not quite. No. Shh. Make sure you're writing notes, please. So our learning intention for this part of the topic is I want you to be able to understand the idea of what a recurrence relation is, but in relation to your arithmetic. So again, you're just going to be adding or subtracting again. So it's not that hard. And I want you to be able to interpret. So what is a recurrence relation? And then understand the information it's giving you, and then be able to construct one yourself. So you need to, first of all, understand what it is, and then secondly, I want you to be able to make one for me. Okay, so that's going to be the point of this one. All right, so here is a recurrence relation. It's a lot of information, a lot of words there, but I'm going to boil it down to two things. Yeah, all it tells you. Okay, so it's a set of instructions. That's the first thing you need to know. It's instructions. And it tells us how to create a sequence. And there's two things that it tells you, yeah? When you see a question like this where it says T0 equals A, what does T0 mean? What do we remember? The start. So all you're saying, all this is telling you is this is your starting number, T0. So whatever it might be. Normally in year 11, they call it A. Fine, that's fine. And then you'll see a bunch of these letters, Tn plus 1. What this means is to get the next term. That's all that means. To get the next number, it's whatever number you have plus, what does common difference mean? Exactly, the number you're going up and down by. So that's the two things you need to know. What's the starting number, and then how much you're going up and down by. That's all a recurrence relation is. That's all it tells you. It's not that hard. So in this equation, or in this recurrence relation, you'll see it as T0 equals A. So again, what's the starting number? And then Tn plus 1, which means to get the next term, because it's plus 1, next number, it's going to be whatever you have plus that common difference. All right, so let's actually put it to practice. I'm going to ask, let's see. Kane, can you tell me in this question, or in this recurrence relation? Okay, but what does T0 mean? What did we learn about T0? It's the start, yeah? So in this question, what's the starting number? Which is equals 5. So the starting number is going to be 5. Samuel, can you tell me if T0 is going to be 5, the starting number, how much are we going to go up and down by? Or how do we get the next number? What do we do? You're going to, what does this tell you here? You're going to add 2 each time. So that means to get the next number, we're going to add 2. If you start at 5 plus 2, that's what that means. So if you try to generate it, let's go to this page. So let's actually write down how do we then generate a sequence. And this is how we want you to do it in year 10 and year 11 so that you can get full marks. Okay, so please follow along. We're up to page, what page is this? It's 8. Okay, so this question here. So how do we generate it? All right, so listing the first 5 terms. Remember, first 5 terms also includes the starting number. So you're going to look for T0, T1, T2, T3, and T4. Which, yeah, I know it's weird to call it T4, but it is the 5th number overall. But it's term number 4. So let's start here. Sienna, what's the starting number according to this recurrence relation? 5. So we're going to go T0 equals 5. That's the first thing. Easy. Okay. Now T1, how do you get T1? So to get the next number, according to the recurrence relation, it's going to be whatever number you have so far or the previous number plus 2. So this is going to be, to get T1, it's T0 plus 5. Okay. Not yet. So Attila, what's the value of T0? No, T0. So it's going to be 5, plus 2. So that means T1 is equal to 7. And then you repeat the process. Just to get T2, it's going to be whatever you have currently. So I'm going to go whatever T1 is plus 2. Samuel. Okay, let me fix that up. T1 plus 2. So what's the value of T1? What is it there, guys? T1 is so far, you've got 7. So it's going to be 7 plus 2, which equals 9. So to get T3, well, that means it's whatever I have at the moment, which is 9. So T2 plus 2, which is going to be 9 plus 2, which is 11. So this is how they want you to show your working out in year 11. Okay, you've got to do it like this. I know it sucks. It's very tedious, but it's not too bad. It's just tedious. That's it. T4 is going to be T3 plus 2, which is going to be 11 plus 2, which equals 13. So there is how you generate a recurrence relation, or using the instructions to actually generate your recurrence relation. Yeah, I'll leave it there. Yes, you have to. You don't have to do it in the second one. You can just write the answers in the second one. I just left it blank for you. That's all right. Please do it. Yeah, it's easy. It's not hard. It's just tedious. That's the annoying thing. Okay, so it's very repetitive. But again, that's what they want you to do. That's what we will teach you. Any questions so far, guys? Any questions? Let me fix this up. Alright, so that's the first 5 sequences, or first 5 terms in the sequence. Alright, if you want to, you can go ahead and repeat it here, but you can just copy down the actual numbers. So, actually, this one's a bit different. So, sorry, I just realized it's different. So let's do the next. Can I do the next one, or we're still going? I'm going to go to the next one. Next one's easy. It's the same deal, yeah? Same deal. So according to this recurrence relation, let's see. What's the question? Which one? It's T1.
Not T1.
Well, it is what it is. All right, I'm going to keep going. Just copy it. It's just use your head. All right, next one. Let's do this one. So this recurrence relation, we need to interpret what it's saying. Celine, can you tell me, what does this tell us? T0 equals 3. What does that mean? You start at 3. Okay, and who haven't I asked yet? Cohen, can you tell me, what does this tell you here? To get the next number, what are you going to do? Add 1.5. Easy. So that means if we're at T1, it's going to be T0 plus 1.5. T0 is 3. And then we're going to add 1.5. So that gives us 4.5. For T2, again, repeat the process. It's going to be T1 plus 1.5. So in this case, it's 4.5 plus 1.5, which equals 6. Okay, T3, same deal. T2 plus 1.5. So in this case, it's 6 plus 1.5, which is 7.5. And then finally for T4, it's T3 plus 1.5, which is 7.5 plus 1.5, which equals 9. Okay, so there's our first 5 terms in the sequence. Now you guys already actually know how to graph it. It's not too hard. But one thing you got to be mindful of is where T0 is. See, where T0 is right on the y-axis. So 0 is going to be 3. So that means your first dot has to be on that line. Okay, where 3 is going to be for T0. T1 is 4.5. So if that's 5, I think it's about here somewhere. So just below 5. T2 is 6. So that'll be about here. T3 is 7.5, so that's probably about here. And then T4 is 9, so that's about here. I think. It's very hard to tell. Just move this up. And so if we've done this all correctly, guys, Samuel, if you've done this correctly, what should the line look like? It should be a straight line. Good. Although mine's not too straight, but it should be a straight line if you've done it all correctly. And then if I was to ask you guys, Karan, how would you describe this graph? Yeah, what's the trend? It's increasing, it's going upward. Good. So when you ask that question, that's what you say. Increasing, going upwards. Cool? Any questions? Not too hard, yeah? Not too hard. Just tedious. That's all this is. So, in essence, that's how you interpret a recurrence relation. It's going to tell you what is your starting number and what is your common difference, or how you go up and down by. So remember, if you want to write it down, I'll write it down here for you. Starting term, and then remember this here is your common difference for any recurrence relation. That's how you interpret what it is. Now, the thing with this as well, though, is you eventually need to also know how to write one or make one. So when you actually make a recurrence relation, which I'll show you in a second, it has to always look something like this. That's what they all look like. So in the SAC, when you actually do it, make sure that your one looks exactly like this. So you're telling me what's T0, and then you're telling me how do you get the next number, or telling me the common difference. All right, can I move on to the next part? Yes, no, maybe? Yeah, all right, let's go to the next part. So this one's a bit annoying. It's just tedious. But for this one, calculate the value of the 10th number in this sequence. So you got to show. You can show in this case you're working out, but actually no, I don't need to show my working out for this. Let's just use a calculator for this. Yeah, it doesn't tell us to. So do you guys remember how to do it on the calculator? Yeah. So you can start at T4 or you can start at 0. I might go start at 0. So for 0, we're starting at 3. Okay, which is 3. And then what's the common difference, guys? Plus 1.5. So you go plus 1.5. This will give us term number 1. Oops. Okay, term number 2, term number 3. And then term number 4 should be 9. Good. So that means T5 should be, in this case, 10.5. Oops. And then T6 will be 12. Term number 7 will be 13.5. term number 8 will be 15, which means that the 10th number, which is T9, should be 16.5. Okay, so that's not too hard. Just use your calculator for that question or these sorts of questions. Because if you were to do it one by one and it asks you to give me the 20th term, you're not going to do all of this, yeah? That's too much. You're not going to do that for the 20th number. Just go and use your calculator for this. Any questions? No questions. No questions at all. All right, it's easy, yeah? All right, we're going to go to the last bit, which is now how do you make a recurrence relation? So making it isn't too hard. You're just following that formula or that form there. It has to look something like this. So how do you make it? Whenever you make one, again, just follow this format. So it's probably a good idea to have this in your bound reference if you want to. But again, just to reiterate, you're stating what's the starting term, and then to get the next term, it's going to be the current plus the common difference. That's what you're writing down on your actual recurrence relation. So let's practice in making it. So here's a sequence. Okay, how do we then do the recurrence relation? So we need to, actually, let's have a look. I can see it starts at 500. Then it goes to 525, then 550, then 575. So what's the common difference without calculating it? 25. Yeah, D, 25. But let's actually do it properly. Yeah, so first things first, let's state the starting number. What haven't I asked yet? Lizzie, what's the starting number here? It's up here. You can see it. Sorry, you don't have glasses. What's the starting number for this sequence? What's T0 basically? 500. Very good. Okay, easy. The next thing we need to find is what's the common difference. So we can actually use this here. Let's fill it out. Anyone want to pick a term we can use? Which term? 550. So we're going to use T2. Take away T1 because it's the current minus the previous. So it's 550. Take away 525. Again, they want you to show working out in year 11, so please make sure you do it. So in this case, 550 minus 525 should be 25. So the common difference is 25. Now we've got all our information to make a recurrence relation. Ooh, that rhymes. I'm not a rapper. So that means T0 is 500, and then the common difference is 25. And that's literally how you write a recurrence relation. So it has to look like this. In the SAC, though, it's not going to have all of this. You have to write it yourself. I'm just making it easy for you now. But in the actual SAC, okay, you got to write it yourself. Just make sure it looks like this. Must look like this. Don't tell me, or don't just write this down, please. You must write the whole thing. Cool. Any questions? Yeah, right. That's pretty much it. I'll stop recording there.